And just waiting for the
Stage
call out
2
for
LOX load is
liquid
complete.
oxygen. Right on time. Stage 2 liquid oxygen loading is now complete. That concludes propellant loading on the vehicle. That means that Falcon 9 is fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Weather is 90% chance of
Ground gas closeout.
good weather for T0. And we are just about 30 seconds away from Falcon 9 going into startup. Now that propellant loading is complete, we are beginning to vent out the lines, the propellant lines on that transporter erector there, so you can see more of those white clouds around the vehicle. Startup is coming up here in a couple seconds.
Falcon 9 is in startup.
Great call out. That means that the internal flight computers have now taken over the launch countdown. We are now just waiting the final go from the launch director.
LD, go for launch.
An excellent call. All systems are go for launch of Falcon 9 with the Intuitive Machines lunar payload.
30 seconds. Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff. Go SpaceX, go IM-1 and the Odysseus lunar lander.
Vehicle pitching downrange. Stage 1 propulsion is nominal.
Falcon 9 has successfully lifted off from Pad 39A at Kennedy Space Center, carrying the IM-1 payload. Now, during ascent, we tilt the engines, the technical term being gimbaling, and that turns the rocket horizontally. And
Mach 1. Max Q. Back shell has started.
Yep. We have a few events coming up in quick succession here. That will be MECO, stage separation, SES-1, and then the boost back burn startup on the first stage vehicle. MECO, or main engine cutoff, is where we shut down all 9 of those M1D engines on the first stage vehicle. That helps slow the vehicle down in preparation for stage separation, which is where the first and second stage will separate. And the first stage booster will begin its trip back to Earth. And the second stage vehicle will ignite that MVAC engine with SES-1, or second stage engine startup 1. And then the boost back burn will begin on the first stage vehicle, which is one of 3 burns that's required for the vehicle to make its way back to today's landing zone. And this burn assists with the vehicle to reorient itself back towards land.
Stage separation confirmed.
And back ignition.
Stage 1 boost back startup.
And there we saw and heard those call-outs for MECO, stage separation, SES-1, and the boost back burn startup on the first stage. Some great views there. Now, the first stage is currently performing its boost back burn. This is where we ignite a few of the engines to bring the trajectory towards the landing site. And coming up here shortly will be fairing separation.
Fairing separation confirmed.
And an excellent view of fairing separation and an amazing view of the IM-1 payload attached to Falcon 9's second stage.
Stage
Fairing
one, boost back
deployment
shut
has
down.
been confirmed, and we will be attempting to retrieve these fairing halves once they fall back to Earth with our recovery vessel, Bob.
Both vehicles are on nominal trajectories.
And some good call-outs there. And in about 3 minutes, there will be a couple more burns on our first stage to prepare for landing at landing zone 1 at Cape Canaveral. Again, we've completed the boost back burn on the first stage. That's the first burn of 3. The next burns coming up will be the entry burn and then the landing burn for the first stage vehicle. Now we are at T plus 4 minutes and 17 seconds into today's mission. IM-1 is SpaceX's 14th launch this year, and the lunar lander on board could be the first U.S. moon landing since the Apollo program ended more than 50 years ago. You can see on your screen that the MVAC engine on the second stage is ignited, and we are currently in the first of 2 planned MVAC burns. Around T plus 6 minutes, you should see on your screen the first stage's entry burn coming up on that first stage vehicle. Again, that is the second of 3 burns. For the entry burn, we will relight 3 of those M1D engines, starting with the center E9 engine, followed shortly afterwards with the E1 and E5 engines. This helps slow the vehicle down as it enters back into the Earth's atmosphere. Now we need to slow down the vehicle to reduce re-entry forces, and that helps us to recover and reuse the first stage. And again, what you're seeing on your screen is a view of the MVAC engine on the second stage. And you can follow the speed and altitude of both vehicles on the bottom left hand of your screen. That is showing the stage 1 telemetry and stage 2 telemetry on your right hand screen. And we are coming up on the entry burn for the first stage vehicle in just about 20 seconds or so. And what you're seeing on your screen on the left-hand side, it's a little dark there, but that is a view from the first stage. And with the entry burn, we should see that screen light up with the engines reignited.
Stage 1, tree burn, startup.
And there you can see that the entry burn has begun with those engines relit.
Stage 1, entry burn, shut down.
Stage 1, FTS.
And a very quick
Both
entry
vehicles are on
burn
nominal
there.
trajectories.
Great call-outs, both vehicles on nominal trajectories. And as I mentioned, that was the second of 3 burns required for this booster to return back down to land. The next and final burn will be the landing burn. That's just a center E9 engine burn, and that helps slow the vehicle down just in time for landing. That's coming up in just about 15 seconds or so.
Stage 1, transonic. Stage 1, left burn.
And there you
Stage
can
2
see on
from
your
terminal
left-hand
guidance.
screen, the landing
Stage
burn
2
has
FTS
begun. Let's
is
watch
safe.
as Falcon 9, let's
Stage
watch
1,
as Falcon 9
left
touches down for landing.
Stage
And a
1,
great
landing confirmed.
view there. That is we just had confirmation of
Nominal
booster
orbit
landing. We
insertion.
also heard and just heard SECO-1 as well as a confirmation of good orbit for our Falcon 9 second stage carrying our IM-1 payload. Now with that landing, that marks SpaceX's 273rd recovery of an orbital class rocket, including first stage landings for Falcon 9 and Falcon Heavy. And with confirmation of good orbit, the mission isn't over yet. Coming up, we do have the second burn of our MVAC engine, or SES-2, on board the second stage around the T plus 41 minute mark, followed by spacecraft separation. So until then, we're going to send it over to Megan at KSC. Megan?
Thank you, Jesse. And if you're just joining us, welcome to the Space Coast of Florida, where we just witnessed live the liftoff of the moon-bound spacecraft and Nova Sea lander called Odysseus. And you know, we see a lot of launches here from Kennedy Space Center, but it really, truly never gets old. So Odysseus launched on top of a SpaceX Falcon 9 rocket from Launch Pad 39A here at Kennedy Space Center. Intuitive Machines, an American company based in Houston, Texas, developed and built the lunar lander that is carrying, among other things, 6 NASA payloads. And if everything goes as planned, in 8 days, that Nova Sea lander is expected to land on the shadowy south side of the moon. Make sure you stay with us. Our broadcast here on NASA TV will continue through Odysseus's acquisition of signal, which is expected to happen around 1:55 a.m. Eastern Time. Now, before launch, we highlighted 3 of 6 NASA payloads on board the Nova Sea lander. The 4th is the SCALPS payload, which stands for Stereo Cameras for Lunar Plume Surface Studies. It includes 4 cameras at the base of the lunar lander. The images it captures will help scientists understand how landings impact the lunar surface for this mission and future ones.
SCALPS is an array of small cameras that will be placed around the base of a lunar lander and collect imagery during the descent and landing of the vehicle. Using a technique called stereophotogrammetry, we can use those images to reconstruct a 3D shape of the ground. As the lander comes down, its hot engine plumes will interact with the surface. Our cameras will begin acquiring images from before this interaction begins until after the vehicle has landed on the surface. The SCALPS cameras will specifically be looking at the overall crater formation and erosion of the ground due to the rocket plumes. The final stereo images, which will be stored on a small onboard data storage unit, will be transferred to the lander and then downlinked to Earth, where we can use them to reconstruct the overall erosion volume and shape of the ground. With the Artemis program, we plan to establish a sustained lunar exploration and try to land multiple payloads in close proximity to one another. SCALPS data will be a critical part of understanding these phenomena and improving our computational models to inform these future landings.